Welcome back. My name is Dr. Darrell Boyd, the chemist, and I am coming to you on behalf of the Transformational Education Adventure Center, also known as the T Center, which is located in McLean, Virginia. I am teaching STEM, that is science, technology, engineering, and mathematics. And today, our lesson is going to be on static electricity. Again, that's static electricity. Static electricity. All right. What is electricity? What is electricity? We're all familiar with electricity through things like the light switch. We think of it that way. And then sometimes we think of it as a lightning bolt. All right, a lightning bolt. Well, electricity takes a number of different forms. One of those forms is stationary. It's a stationary form of electricity, and it's called static electricity. Static because it's stationary, it's in place, it's in existence, but it's not moving anywhere. Normally we think of electron as the travel through electrons. I'm sorry, electricity as the travel through electrons. But static electricity, they're just sitting there waiting to transfer to something, all right? And that's why it's static electricity. Where do we see static electricity? Well, we see static electricity pretty often, especially when the air is dry. So perhaps in the cold of the winter time, you're very familiar with static electricity. Why? Well, because if you're wearing a sweater, it causes your skin to, the hair on your skin to rise up, or it may shock you, all right? So we get static electricity in those types of conditions very often and really commonly. But you can actually build up static electricity. And I imagine that you've seen this before, okay? I have here a balloon, and the balloon is gonna build up some static electricity. And so I'm gonna show you how. I'm gonna take this balloon and I'm gonna rub it on my shirt. That's all, just rub it on my shirt. And now watch. I can get the balloon to stick to my hands if I rub it on my shirt and build up enough static electricity. Oh, it doesn't want to work there today, but if you build up enough and your hands are not too oily or wet, you actually can get the balloon to stick to you. Ah, there we go. Pretty good, huh? You see that? No magic here. It is just sticking to my hand as a result of static electricity being built up along the surface of the balloon. So what is happening in a scientific sense? Well, when I rub the balloon on my shirt, and you might try rubbing the balloon on your hair, or if you have a sweater or carpet or rug, it'll work that way too. But I'm just rubbing it here on my shirt. Now, when I'm doing that, what's happening is I am causing the charges to align. What is a charge? Charges are positive and negative. So there's positive charges and there's negative charges. And they're all over the place. They're all around us. And in fact, why lightning comes from the cloud to the ground, it's looking for charges, all right? Charge in the sky, finds a charge in the ground, and out of the cloud comes that lightning bolt, okay? So the charges, positive and negative charges in this balloon, when I rub them along a surface like my shirt or my hair or a sweater or some carpet, what's happening is the charges are actually aligning. Meaning the positive charges are all getting together and the negative charges are all getting together. And where do they line up at? They're lining up on the surface of the balloon. All right, your negative charges are going to line up on the outside and your positive charges are going to line up on the inside. And they're very uniform. Well, when you get enough charges together, you can actually do some pretty cool things, like cause the balloon to be stuck to someone's hand, okay? But you can do more than that even. You can begin to shock things, right? So if you build up enough static electricity, you can actually take your fingertip and touch a doorknob, a metal doorknob, and you'll feel a little shock. It'll go, and if you do it at night or in the dark, you can actually see a little flash of light from the electrical charge that goes from your fingertip to the doorknob. All right. Not only can you shock things or see a shock or a charge when you build up enough static electricity, you can actually begin to move things. And that's what we're going to do today. So I have with me a balloon and I have an empty soda pop can. All right. Well, can I move this can with static electricity? Can I move the can with static electricity? Let's find out. So again, I'm gonna build up charge here. I'm gonna build up a lot. I think I'm gonna need a lot if this is gonna work. Here I go. Oh, you might have noticed there was a little sound of it, like that, a little pop sound. That was the charge from the balloon transferring to this can here. And the can didn't move. That's because the charge had been discharged, all right? Well, that does work sometimes, but what if I put this can on its side? What if I do that? I'll put the can on its side. And notice the can is not really moving right now. Now I'm gonna take this balloon. Check it out. All right, so I can in fact move this empty soda can by putting the balloon, which has a lot of charge on it now, near the can. It works easier when the can is on the side because then it can roll, but believe it or not, you can get it to work in this position as well. Let me see if I can try it before. This may or may not work, I'm not sure, but I have done this plenty of times before, so I know it's possible. See if I can get this can to move in this position. You see that? It's moving. All right, so there, you can see that it will move. It's just much easier when you can put it on a side, because you can roll it. You can bring it one direction or another and move the can around, all right? Why is the can moving as a result of the static electricity? Like, what inside of this can is causing it to be pulled toward this balloon? If you guessed that it also has charges, you are correct. There's charge in the can. And in fact, they're going to, when they come near this balloon, the charges in the can begin to align, just like the charges in the balloon have aligned after I charge it up. And remember, opposites will attract. So a positive and a negative charge are going to want to come together. And so all these negative charges here on the balloon are going to be drawing attention or attraction from the positive charges in this can, which are now aligning, all right? And when they align, they get close enough together, you can actually move the can, because the can also has positive and negative charges that can be aligned. And as a result, they can be affected by coming near the opposite charge on that surface, all right? So we have negative charges and positive charges aligning on the outside and inside, respectively, of this balloon surface once I charge it up. And then we're gonna have positive and negative charges on this can, which are now aligning, and they're gonna be attracted to the opposite charge on the surface of the balloon. And that is static electricity. So before we go today, I have a challenge for you. If you have done this at home, you've gotten a balloon, you've gotten an empty can, you charged it up, the balloon, and you brought it near this can, and the can is moving, and you get the can to move back and forth, all right? If you have done that, here's a challenge. Put the can aside, go to your kitchen sink, turn the water on at the water faucet to just a really small, tiny stream, not a big flow of water, but just a tiny stream, a steady, tiny stream, all right, of water flowing out of your water faucet. Charge your balloon up the same way you did with the can, and then put the balloon near that stream of water. What you should see happen is that the stream of water begins to curve toward the balloon. Why? Water is a molecule that we call polar, meaning that it has positive and negative aspects to it. It has what we call a partial positive and a partial negative charge. The imbalance in those positive and negative charges means that you can actually attract water by pulling on the water with something that has a lot of charge, like this balloon that we have charged up. All right, give it a try. Charge your balloon, a nice good flow of water, not a big gushing flow of water, but just a good stream coming out of your water faucet. Put the balloon near it and watch what happens. All right. Well, that is our lesson today. I hope that you learned something about static electricity and how powerful it actually can be. It is a pretty strong, it's among the weakest forces, but it's strong enough to be noticeable, and it can have an effect on lots of things. All right, I hope you enjoyed the lesson, and I will see you later. Take care.